A great pleasure to be here and to share our idea and our research. This time I will speak about new topic, para and ortho isomers. As they was already mentioned here in several presentations and in posters. This collective work, we do this in several laboratories, and we focus on measurement aspects. I would like to start with a short introduction. We should mention driving forces in the water research, why basically we do this water research and what is so interesting in the water. I think there are four different driving forces. One is, of course, biochemistry, living organisms. We consist mostly of water. And ecology and the biosphere, also life without water is impossible. And of course, we have a huge social request to do research, to discover some devices, results, to use it in life science. But we also have industry as consuming water. The largest is, of course, agriculture. We have pharma industry. We have industry with wastes. We have bottling, filtering, all these people and industrial fields who give us basically money and asking for specific research and asking specific questions that we should answer. And we have some, curiosity-driven research based on some subtle effects, some consciousness, all this fancy stuff what we are doing. It's first a scientific, second industrial. In all these, at least four areas, we discover some, I would say, unusual properties that not really well described by a classical understanding what water can be. And, somehow to reflect all this idea, there is some research lines. Of course, list is incomplete. I think every researcher proposed something own. But it seems that last, mostly I think 10 years, we observe a kind of clusterization. One of the most probably prominent is different ice-like blocks in water, what are discovered. And there is a lot of great publication, for instance, in Nature, or last publication in Journal of Chemistry. So we can really trust this level of publication that we discover some structures that prevent water molecules from this, random motion that's froze somehow. Second, a large cluster, of course, what Jerry, I checked this huge list of publication, what was listed in Jerry's homepage. This absolutely impressive. We should here also see different surface phenomena based on water evaporation, surface tension. All of these crazy ideas with, for instance, energy transformation surfaces. And lastly, this new domain, para and ortho, it's mostly related to nuclear idea about atoms, also a lot of publication. We should also, one point what we discovered in the publication, we should think on all these areas as a different mechanism working probably in parallel in water. So we definitely face different effects happening from different sides. And so when we try, to pick up some combination of these different mechanisms. So I will focus, at least in this presentation, this para and ortho idea. Generally, sounds somehow, complex, nuclear isomers, but in theory it's rather simple. Yeah? We have water molecules, oxygen, hydrogen, and hydrogen, they have a rotation, and they can rotate in the same direction or in opposite direction. And if you just consider this from a little bit far away and say, well, it's probably interesting for some small community, but publication demonstrate very clearly that isomers have very different physical and chemical properties, and in fact we have two different molecular species in the same fluid. So just to think, we have water, ordinary distilled water, But this distilled water, in fact, consists of two molecular species, and equilibrium, they have equilibrium about 3 to 1 in para or ortho isomers. But it's flexible, and so by varying these isomers, you can have very different properties. I mean, you know, we all over these years, we do crazy experiments and demonstrate that we have changing ionic contents, we have changing all this pH and whatever. It seems it's very simple, explainable. We don't need even to call this unconventional. It's fully conventional if we consider just two different molecular species that switch to each other. So this, I think, is one of the point. My point. We don't need really to think of unconventional science. I mean, there's a conventional science. Just we probably do not understand some issues, and we, you know, my goal is more or less. I see this as a conversion in one large probable area of conventional science. So. And there is a lot of publication. There is for recorded version. I mean, you can check it in the recorded version. Now, one of key point why this story is of interest, because we have one side chemical sides, we have different chemical reactivity, and I think I just realized discussion with Elke a couple of days ago here. Elke said, well, different water energy. Water energy somehow sound ununderstandable for me, but you said it's a different reactivity, and indeed, isomers have different chemical reactivity. One reacted more intensively, and I mean, this difference what was measured in publication about 23%. It's a huge difference. Think about biochemistry behind. So indeed, it can be understood in terms of, let's say, energy, and switching between the isomers, you change energy. To some extent, of course. We have different physical properties. We have surface tension, viscosity, conductivity, interaction with magnetic and electric field. We have really different chemical side. In quantum, because spin are quantum objects, in quantum side, of course, we have spin-spin interaction. We have light matter interaction. We have all these crazy quantum effects like xenon effect, like common wave function, like entanglement. And so it seems this mechanism can be used as a kind of converter between quantum, from quantum to chemical, and from chemical to quantum. One of the most important things here, there was first described by Serge Kernbach about 10, 15 years ago, that energy conversion, this spin conversion, that required quite a low energy. And it can take place in the fluid phase. So this is a kind of key point. There was our replication study exactly related to this point, that we can do this with extremely low energy, also at the level of variation of Earth magnetic field, so it's very low energy, and in different ways, so hydrodynamic cavitation, magnetic field, light, I mean, all these different ideas. So one of the main points here, we can use it really as a sensing mechanism for these all weak effects. And we have done it. And this is my first point, just a replication study of Sergei, what he done in the laboratory. Again, the idea here of this quantum level sensor, it's very important. We should have a chemical reaction, a controllable chemical reaction that kinematic is understandable for you. We used at least two different reactions. We use CO2 dissolving through carbon dioxide and different ions. And in the same way, we use also oxygen pathways with hydrogen peroxide, with reactive oxygen species. In fact, we receive the same results as in publications mentioning. The idea is here, well, you have a chemical reaction that you understand, and here you apply a treatment for, let's say, physical treatment in terms of light, you shackle this or whatever you do. Or even you do this in quantum way, for instance, light matter, so you apply different photons with specific energy and you changing levels, energetic levels, or you create more, let's say, crazy stuff with wave function or entanglement. So, there are different names, of course, for this, imprinting or information or putting energy, but we call it physical and quantum treatment. So you change here water and isomer, they generate different reactivity. So, and end of this reaction, you will have a different number of ions, and what you do, you just measuring this amount of ions in the first way and in the second way. So, like I said, there's nothing, let's say, special here. Important here, these products can be measured in electrochemical way. For instance, we apply impedance spectroscopy, or it can be done in optical way by absorption spectroscopy, or even using just measuring physical properties. So we measuring surface tension. So these things can be detected in multiple ways. But main point, like I said, you should understand this chemical reaction that produce different chemical reactivity. So this replication study is published. We published first in the Journal of Electrochemical Society, and then we discovered a lot of side effects, and we try to publish the side effects as well. This is setup. We have two samples. One sample is applied to magnetic field, also extremely slow magnetic field. We specifically go to the range of 50 microtesla. Just to give you idea, variation of Earth magnetic field is about 50, also 40 microtesla, between 30 and 60 microtesla, something in that range. So our minimal range is a variation of Earth magnetic field, and we go up to 1 millitesla. I mean, in normal, publication, usually you start with 1 Tesla and go to whatever 10 Tesla or in millitesla area. The microtesla, it seems, up to now is not really as measurable. But here we apply extremely low magnetic field. Here is some, let's say, from the paper, some of these results. Here we, in this, who use our equipment, know this small containers. Here is a hole for CO2. There's more or less new in this whole stuff. So, you can use this for about 1 day of measurement before you saturate with ionic products, or you change water and you can start new experiments. So here is one of result, this CO2 pathway and this dissolved oxygen pathway. And here is about, let's say, applying magnetic field about 50 microtesla, and this about 500 microtesla. Okay, point what we are going to see, different ionic productivity, in fact, is a change of the slope. So black is a control and red experimental. And you see, after application of magnetic field, you see a changing reactivity. Also well visible is already with something like 200 microtesla, 150 microtesla, but even it's still measurable at the level of something like between 50 and 70 microtesla. Point of that experiment is quite, we would like to demonstrate that whatever is happening with our magnetic field, Earth magnetic field, that influence, of course, properties and the level of productivity, ionic productivity. And since we have a lot of water in our body, so it's directly impacted our physiology. And of course, if we drink it, it's our impact also through drinking way, all these biochemical processes. So variation of Earth magnetic field has an impact also through this mechanism. So, and here, for instance, in the hydrogen peroxide, it's the same. Even in the lowest area, we already see something like a little bit more, let's say 150 microtesla, we observe different electrochemical reactivity. So it's well detectable. The whole story is a little bit more complex, and because these reactions are reversible, so we have sometimes, changing reaction pathways. It's good because we can characterize. And here is one of the point, in the measurement community, then everybody say, we would like to detect something. Okay, we apply whatever impact factor, and we compare control as a non-treated with treated, and we're absolutely happy if we see any differences. Yeah, say, yeah, we done it. Here the point is to characterize, and characterization, in the community we try to achieve it as a long time, and exactly this mechanism of reversible reaction give us characterization, because we can characterize in terms of different ionic species, and they have a specific saturation level, and we can basically see saturation switch on, switch off, and we have here electrochemical, we call it electrochemical markers. So each, let's say, treatment approach, and is especially important, state of water before treatment, treatment approach, environment around your system, use stage, can be characterized by electrochemical markers. So this is one of really nice things because we can give more information, whatever reason this information will be used. So we can do this. Here, another point which we had a lot of discussion, comparison of electrochemical and optical methods. Here's the impedance spectroscopy. You see, I mean, treated, untreated, absolutely well visible, even at the lowest level. Here is absorption spectroscopy before, in ultraviolet, less than 260 nanometers. We also see quite clear spectral line. The point is we can detect it not only with electrochemical, but with optical methods. But the difference is in price of equipment. Here, I would say price is about 500 euros, but here is about 3,000 euros, so the factor 5 in the cost of equipment. Just short slide, surface tension. Like I said, it can be detected not only in ionic contents or chemistry, but even physical properties. Here is really a surface of the water here. It's it's a surface tension, absolutely crazy object for investigation. And we measure this by electric fields. It's quite precise. And you see applying magnetic treatment, we see the whole oscillation. I mean, this detectable, well detectable even by viscosity measurements. So, extremely nice, extremely sensitive methods for measuring. But it can also use for explaining things what was not explainable before. And one of things is thermodynamics. If you encounter some thermodynamic anomalies, then you made a mistake. All these evaluators say, yeah, please check. Do not submit even this paper. Do not think of submitting it. Yeah? But here we can explain these thermodynamic anomalies. And why? Because of different heat capacity of isomers. We know from hydrogen that isomers have different heat capacity, and if we have a spin conversion mechanism in water, of course it will change heat capacity. So it means we can easily generate thermodynamic anomalies in our samples. And we discovered this effect first in China. We experimented with Qigong, and Glenn was somebody who proposed this experiment, and our colleagues in China organized well-known Qigong master, and it's absolutely crazy experiment. There's a young person, more or less, this well-known in China, and she's standing and projecting qi, external qi or consciousness, whatever. We put all this measurement equipment behind this Faraday cage. It's a huge wall. It's protecting from electromagnetic emission. Also in China, it's a really top equipment in that way. And what we saw, changing, of course, of electrochemical properties, but most important, here is visible, we observe change of temperature inside of these containers and then outside. From thermodynamical point of view, make absolutely no sense. So first you have changes in environment. They go inside, and you detect first here and then inside. We detect first inside and then outside. And then we say it should be some mistake. It's impossible. Yeah? Then if we return from China, this was exactly 1 week before pandemic started. Yeah, I was happy to return to Stuttgart. As we return, we started to think about this and to develop new setup, also colorimetric setup, absolutely passive setup without any electrochemistry. There was a kind of, let's say, a little bit painful development because we easily, detecting, the measuring temperature is simple up to a specific level. If you go down, you should be very careful what you are measuring. So more or less, it's a triple differential measurements with 6 temperature sensors. So we're measuring here this for spin conversion, 2 container for spin conversion, 2 differential conversion for air temperature, and 2 differential container for external temperature. So absolutely, crazy measurement equipment behind with all this 30-bit ADC conversion, all these things. Then we put this setup a kind of, this should be passive, also what we learned lecture, it should be passive colorimeter. It should be no any infrared heater or whatever, absolutely passive. And then we put in one box, then this box we shoot in another box, then the whole laboratory, is shielded. And then we almost sacrifice the whole laboratory. But what we achieve a kind of absolutely stable variation of temperature, about 0.001 variation, so it's really stable environments. And then we invited, Qigong master has a kind of mental influence, at least we assume. And we know that masters for meditation are Buddhist monks. We invited several Buddhist monks in experiments, and we have some people in our laboratory. So 5 people, 3 months, over 90 attempts, control experimental attempts. Goal is quite simple. Try to sit down in this laboratory about 10 meters away, and try to change thermodynamics in the container. Just try to create different temperature in the water container. So make wonder from the point of current science. And indeed, session was 30 minutes. And here you see a curve. This is temperature of water containers, so left and right. And this is air temperature. So in air temperature, we do not see any differences, but we see a difference in the water. So these people in 10 meters away are able to generate different temperature in absolutely passive system. No electrochemistry, no heating, nothing. Just by focusing your attention, that people was able to change temperature in the containers. Sound absolutely crazy. These experiments the next day. This is differential now as a result, but represented in differential way. Here between air containers, you see no changes in temperature. Differential is around 0. But here you see, increasing change of temperature between water containers. We receive, in fact, extremely high reproducibility, about 90%. It's one of the best, let's say, sensors that we ever had in the hands. Even it's passive, absolutely passive, but it's one of the best. So we're publishing this. I'm, excited what will be evaluation. But one of our points here, these healers and Reiki people, they focus on the human body. And now if you focus attention on the human body, of course you have a lot of water inside of a body. There is even known effects as persistent temperature changes if you make a treatment, but temperature that still remain in the body for a long time. So up to now there was no explanation. We repeated this with yoga tuma, and we also see this long-term changes. And the point is, probably we also have in our body spin conversions, but this is more or less, it's more complex because it influences our biochemistry, and this just a concentrating attention on human body start this change of biochemical reaction, starting from nuclear isomer level. So that's more or less my main message. Okay, discussion and conclusion. One of important point so there are dozens of different topics. One of important topics what I think will be a kind of focus for next years is the spin-spin interactions, because still as a long distance, as a non-contact, long distance means centimeters or meters or kilometers, it's not explained. So there are a long list of discussion and possible topics from entanglement up to spin-spin. So here we explore this, for instance, in terms we have different electrochemical oscillators. So they oscillate, and if you have here no sources of light or electromagnetic emission or whatever, they should not correlate. But what we see a correlation between electrochemical oscillators. And the question is why? From chemical point of view, we know why, but what is behind this oscillator, we don't know. Even if we switch light, here there's no light, absolutely isolated, we still hear a high correlation between electrochemical oscillators. And discussion in the community is what it is. These are colleagues in theoretical domain, whether it's a kind of spinor field, what we see, or is a kind of quantum phenomena, or this Rabi effect, probably a kind of Rabi effect, magnetic field. In fact, we don't know. I think there's a kind of open aspect what we will work and probably present next time. But this is definitely probably in this way we can explain effects of pop, of Kazanachev, all of these crazy long distance effects. To conclude. what I think para and ortho is of course complementary. It's complementary to all other studies, but it can, I mean, contribute in explanation of some unusual properties. At least it's absolutely, I mean, conventional to see different property, physical and chemical properties from pure water. I mean, that's nothing essential from this point of view. There is a discussion, of course, in which stage they take place. So classical gas, because of, you know, you can dilute gas and there is no also less collisions. And people say, okay, in fluid phase you have a lot of collisions, so there is no way that you have a spin conversion in fluid phase. But what Sergei said, and basically what we confirm, and now so several laboratories confirm this, that in fluid phase, if molecules are frozen in this ice-like structure, we also have a spin conversion. So, and publication are in the surface, so we have also spin conversion on the surface phase. So it means that in all three phases, we have experimental evidence that spin conversion take place. So, and other materials as well. So we have hydrogen, we have methane, we have ferrum-3 with spins. So the whole field of quantum biology work now with spin conversion, all the spin phenomena. And what I think personally, you know, we are measuring laboratory. I think that it's a kind of new quantum level sensors. So extremely sensitive, so with a possibility to characterize, and a kind of new step in the whole development. And the fourth point, what I didn't write, but I say this, you know, human consciousness, we demonstrated in previous time, and even we have now the system, this mind system that's running, I mean, all this, in pandemic time, a lot of people experimented. We have even here many persons who experimented here. So consciousness can change over the whole globe. So again, over the whole globe, electrochemistry of aqueous solutions. And here we demonstrated that even consciousness can change thermodynamics. Also, of course, a very low level, not a huge level, but nevertheless, if you have some, you know, balanced condition and you can easily, you know, switch the system in bifurcation that way or in that way, human experimenter can contribute and influence the result of experiments. So, you know, that's, so therefore, please think about this. Thank you.
Thank you, Serge, for again an enlightening presentation. It makes me think of Brenda Jonen, who was part of the peer research laboratory, and in an initial interview with her and Robert John, she said, hell, we didn't know the answers. We didn't even know what questions to ask. And if you look at what you're researching, I can imagine that sometimes you see results and then you don't know what questions to ask. Which brings me to you, so maybe one of you has a question to ask, and I see Jerry pointing his finger, so Jerry, please go ahead.
In your magnetic field experiments, so in the interpretation of it, I'm just wondering whether something we found very recently might have an impact. So we found that if we immersed in water a magnet, a neodymium magnet, so a stronger magnetic field, we put microspheres in the fluid. We found that an exclusion zone builds over a period of 15, 20 minutes or so next to the North Pole and next to the South Pole. And we didn't expect this, but that's what we found. And I'm wondering whether, you know, if what we found is really correct, then the properties of the aqueous solution are changing. So I'm just wondering whether there could be any relation between what we found and what you found.
There are multiple mechanisms. Yeah? There's not only single mechanism. We have surface, of course. We have easy. We have all this para-ortho. We have structuring. You know, we have frequencies, of course. They should work together. Yes. If you put, you know, magnetic field, or there are many structures, you know, in water that are sensible to magnetic fields. Yeah. The definitely will be kind of cross correlation. You know, there are kind of self-amplification effects. So with, for instance, with some coherent domains, they are some self-amplified. Yes, definitely, yeah.
We have one question from Zoom. You can read it on the screen.
Oh yes, it's a good question. I mean, we have, of course, a hypothesis. A hypothesis that is quantum biology. So in neural activity, we have a lot of quantum mechanisms, in particular some spin phenomena, spin phenomena, and we in fact assume we work like a quantum computer. But quantum computer not only, with non-living material, we have partially living material in our brain, we have some pieces of water, but it's more or less, it's work in the manner of quantum computer, kind of huge distributed whatever. We even don't know all these properties of this quantum computer, but it's more or less, it's a kind of future direction, as a thinking way along this quantum computer. So it's a good point, yeah.
So I think in view of the time and all the discussions you will probably provoke, we have time for 2 more questions. There's one here. So.
I enjoyed it very much. Thank you. My question is very elementary. I wondered, I saw your chemical equations written. For example, H2CO2, okay? Dissociate into what you wrote, a proton and another molecule. Is this proton a hydrogen? Is this an hydronium ion? Or is it a free proton? We should be careful to differentiate between this.
Yes, I mean, there's a well-known discussion, of course. I mean, you're absolutely right. But what we wrote is a kind of representation for just a better understanding. But yes, I know this discussion. Yeah. Even if we publish this, there's always a discussion from theoretical point of view, what is, let's say, basics of physical chemistry. Yeah.
So we have one final question for this session.
Thank you. I'm very interested in the stability of the ortho para that we discussed yesterday.
Yesterday.
Yeah. So the article says, I mean, they divide it with the magnetic field, and then they actually last more than 20 minutes. There is still an ortho water, and you have a para water. Eventually, it goes back to a mix of 75% ortho and 25% para. I mean, I'm thinking like, so the hydrogen bond is lasting 10 picoseconds. Of course, it's not that the water molecule breaks down totally, but some of them rearrange. Do you think that is the mechanism, or do you have any other idea?
I think, I think it's an open research point. This conversion in water, was expressed by Persson as a hypothesis. They confirmed this with far infrared, I think, measurements, with optical measurements. They develop absolutely crazy device for this. We use this electrochemical and optical methods. It seems that conversion really takes place in the fluid phase. This is a key point. Okay. Next key point, or key question is what is the conversion time to equilibrium, so from non-equilibrium to equilibrium. Yeah, Sergei considered it as overheated fluid to spin temperature. Question is, okay, what is the relaxation time? There is a discussion. If there is a possibility to invite Sergei Persson to give talk here, probably he can, elaborate our understanding of this approach. So Sergei is a brilliant scientist. Yeah. No, that's more or less a little bit disappointing answer.